November 7, 1965. The thunderous roar of helicopter blades shattered the humid stillness as Specialist 4th Class Michael Patterson felt the full burden of war settle onto his shoulders literally. Strapped across his back, the M60 machine gun weighed 23 pounds unloaded, and with 200 rounds of linked ammunition draped across his torso, he carried nearly 40 pounds of killing power into the green hell of the Central Highlands. He didn't know it yet, but the weapon that Army propaganda promised would revolutionize infantry warfare was about to become his greatest liability. The M60, designated officially as the machine gun, caliber 7.62mm M60, arrived in Vietnam with fanfare and expectation. Designed to replace the aging Browning M1919, the weapon represented American industrial might and technological superiority. General William Westmoreland himself praised it as the finest light machine gun in the world, believing it would provide American squads with overwhelming firepower against the Viet Cong and North Vietnamese Army regulars. Patterson and thousands like him would soon discover the chasm between Pentagon promises and jungle realities. The helicopter descended into landing zone Albany, and Patterson's platoon disembarked into waist-high elephant grass. Within minutes, the oppressive heat transformed his uniform into a sodden second skin. The M60's weight seemed to double with each step, the metal components conducting Vietnam's brutal temperatures directly into his flesh. The weapon's bipod, theoretically useful for stabilizing aim fire, snagged on vines and vegetation with maddening regularity. Patterson struggled to maintain formation, falling behind riflemen carrying the lighter M16s and M14s. His assistant gunner, Private First Class Robert Chen, carried additional ammunition belts, spare barrel assemblies, and cleaning equipment, another 30 pounds of burden in the suffocating jungle. The two-man team represented the squad's primary firepower, capable of delivering 550 rounds per minute when conditions permitted. But conditions in Vietnam rarely permitted anything approaching ideal. According to a comprehensive after-action report filed by 1st Cavalry Division operations officers, and later referenced in military journals analyzing Vietnam-era small arms performance, the M60 exhibited critical failures within the first 6 months of widespread deployment. The document, compiled from dozens of field reports, detailed mechanical breakdowns, maintenance nightmares, and design flaws that cost American lives. Patterson's squad pushed deeper into the jungle, hunting an enemy that refused to fight conventionally. The Viet Cong mastered ambush warfare, striking with devastating speed before melting back into the vegetation. In such engagements, every second counted, and the M60's complexity became a fatal handicap. The weapon featured numerous small part spins, springs, and components that could work loose under the constant jarring of jungle movement. The gas system, designed to cycle the weapon's action, proved temperamental and prone to carbon buildup in Vietnam's humidity. As shadows lengthened across the jungle floor, Patterson checked his weapon for the 20th time that day. The feed tray cover, held closed by a simple latch, felt loose. The barrel, designed for quick changes during sustained fire, rattled slightly in its mounting. He didn't voice his concerns to Sergeant Davis, who led the squad with practiced calm, but unease gnawed at him. Somewhere ahead, the enemy waited, and Patterson would soon discover whether American technology could match Vietnamese determination. November 8, 1965. The first rays of dawn filtered through the triple canopy jungle as Patterson's squad established a defensive perimeter along a trail junction. Sergeant Davis positioned the M60 to cover the widest field of fire, and Patterson settled behind the weapon, feeling the damp earth seep through his uniform. The jungle awakened with sounds of birds and insects, masking deadlier movements in the underbrush. The ambush erupted at 0700 hours. A -47 round snap through foliage, bark exploding from trees as Viet Cong fighters opened fire from concealed positions. Patterson's training took over, thumbs pressing the butterfly trigger as the M60 roared to life for 5 glorious seconds. The weapon functioned perfectly, spinning brass casings and delivering suppressive fire toward muzzle flashes. Then disaster struck. The ammunition belt twisted, failing to feed smoothly through the weapon's mechanism. Patterson yanked the charging handle, attempting to clear the malfunction, but the belt had kinked inside the feed tray. Precious seconds evaporated as Chen tore open the cover, extracted the jammed rounds, and repositioned the belt. Enemy fire intensified, rounds striking the log that positioned for cover. Patterson's hands trembled not from fear, but from fury at the weapon's betrayal. When the M60 resumed firing, Patterson felt the barrel heating rapidly beneath the perforated metal handguard. The weapon's design called for barrel changes every 10 minutes during sustained fire, but combat rarely accommodated such niceties. After burning through 150 rounds, the barrel glowed cherry red, and the weapon's accuracy deteriorated noticeably. Rounds scattered wide of their intended targets, wasting precious ammunition that Chen struggled to replace under fire. The firefight lasted 17 minutes, though it felt like hours. When the Viet Cong withdrew, melting back into the jungle as suddenly as they'd appeared, Patterson's squad counted their blessings. No casualties this time, but the M60 had malfunctioned 3 times during the engagement. Sergeant Davis knelt beside Patterson, examining the weapon with troubled eyes. Carbon residue caked the gas cylinder, and the feed tray showed signs of warping from heat stress. Historical analysis conducted by Army ordnance experts and documented in the Journal of Military Technology revealed systematic failures in the M60's design that became apparent only under combat conditions. The weapon's gas system, borrowed conceptually from the German MG-42, worked flawlessly in temperate European climates, but struggled with Vietnam's combination of extreme heat, humidity, and fine dust. The feed mechanism, designed for reliability, proved vulnerable to even slight distortions caused by thermal expansion. Patterson spent the afternoon performing maintenance, disassembling the M60 into its component groups. The gas cylinder required aggressive scrubbing with a wire brush to remove carbon buildup. The feed tray pulsed tiny mechanisms that advanced the ammunition belt needed careful inspection and lubrication. But Vietnam's environment worked against such efforts. Cleaning lubricant attracted dirt and dust, creating an abrasive paste that accelerated wear. Too little lubrication caused parts to bind. Too much created fouling problems. As darkness fell, Patterson reassembled his weapon, testing the action repeatedly. The M60 felt looser, less precise than when he'd first been issued it 3 months earlier. Wear patterns showed on the bolt face and feed tray rollers. He wondered how many more firefights the weapon could endure before suffering catastrophic failure. Chen distributed fresh ammunition belts, and the squad settled into their night defensive position. Somewhere in the darkness, the enemy waited, patient and deadly, while Patterson nursed a machine gun that seemed determined to fail him when he needed it most. December 22nd, 1965. Rain hammered Patterson's position with relentless fury, transforming the firebase perimeter into a morass of red mud. The monsoon season had arrived, and with it came fresh torments for the M60 gunners scattered throughout the Central Highlands. Water streamed into every crevice of the weapon, pooling in the feed tray and soaking ammunition belts despite desperate efforts to keep everything under ponchos and plastic sheeting. Captain James Reynolds, commanding Bravo Company, filed a scathing report to battalion headquarters documenting the M60's performance. During monsoon operations, his words, preserved in the classified Army documents, pulled no punches. The M60 machine gun is fundamentally unsuited for sustained operations in tropical environments. Rust forms within hours despite constant maintenance. The weapon requires complete disassembly daily to prevent corrosion-induced failures. Patterson discovered the truth of Reynolds' assessment firsthand when his squad departed on patrol. Within 2 hours of movement through rain-soaked jungle, the M60's exposed metal surfaces showed surface rust. The weapon's phosphate finish, adequate for temperate climates, offered insufficient protection against Vietnam's aggressive moisture. By afternoon, when the squad established a hasty ambush position along a suspected enemy infiltration route, Patterson opened the feed tray to find rust particles contaminating the mechanism. The enemy found them before Patterson could complete emergency maintenance. NVA regulars, better equipped and trained than the Viet Cong guerrillas, advanced in disciplined fire teams. Patterson squeezed the trigger, praying the weapon would function. The M60 fired 7 rounds before jamming solid. Rust particles had contaminated the gas system, preventing the bolt from cycling. Chen worked frantically to clear the stoppage while Patterson grabbed his M1911 pistol, the squad's firepower suddenly reduced by half. Sergeant Davis ordered withdrawal, and the squad fell back through the jungle under covering fire from riflemen. Patterson humped the dead weight of his useless M60, unable to provide the suppressive fire that might have saved lives. Private First Class Timothy O'Connor, the youngest member of the squad, took an AK round through the shoulder during the retreat. The wound wasn't fatal, but it might have been prevented if the M60 had functioned. That evening, back at the firebase, Patterson stripped the weapon completely. The internal components told a story of systemic failure. Rust pitted the gas piston. The operating rod showed corrosion where chrome plating had worn through. Most alarming, Stress cracks radiated from the receiver's locking shoulder metal fatigue induced by thousands of firing cycles under harsh conditions. The weapon that Army procurement officers promised would last years was disintegrating after months of combat use. Technical bulletins began circulating through supply channels, acknowledging problems and offering solutions. Soldiers received instructions to apply heavier lubricants and perform more frequent maintenance, but such advice rang hollow to exhausted infantrymen operating in conditions where simply staying alive consumed every waking moment. Patterson and his fellow gunners needed weapons that worked despite neglect, not temperamental machines requiring constant nursing. Lieutenant Colonel Harold Moore, commander of 1st Battalion, 7th Cavalry, shared Patterson's frustrations. Moore, who would later achieve fame for his leadership during the Battle of Ia Drang, repeatedly petitioned higher headquarters for better weapons. His correspondence, now preserved in military archives, documented M60 failure rates approaching 30% during sustained operations. Moore understood that superior American firepower meant nothing when weapons failed at critical moments. Christmas approached, but there would be no peace in the jungle. Patterson cleaned his M60 once again, applying every trick and technique he'd learned. The weapon was slowly dying, and he knew it. Replacement parts remained scarce, trapped in supply chains stretching back to depots in Saigon and Oakland. He would enter the next firefight with a machine gun held together by determination and prayer. January 14th, 1966. Patterson rotated back to base camp for a rare 3-day stand-down, and he immediately sought out Sergeant First Class William Tucker, the company armorer. Tucker's makeshift workshop, established in a sandbag bunker near the motor pool, had become a sanctuary for soldiers nursing dying weapons. The floor lay cluttered with disabled M60s, each telling its own story of mechanical failure and design inadequacy. Tucker, a career soldier with 17 years of service, had witnessed the evolution of American infantry weapons from the reliable M1 Garand through the troubled M14 to the current generation of Vietnam-era arms. He spoke with the authority of experience as he examined Patterson's weapon, his practiced hands identifying problems with disturbing speed. The barrel showed excessive throat erosion. The bolt-locking lugs displayed abnormal wear patterns. Most concerning, the receiver itself had begun developing hairline cracks near high stress points. "This one shot," Tucker announced, his Texas drawl heavy with resignation. "Receiver's compromised. Keep firing it, and you'll have a catastrophic failure probably blow the feed tray right off." He gestured toward a shelf holding 3 M60s with similar damage. "I've got 23 machine guns awaiting depot-level maintenance. That battalion says we won't see replacements for another month. Meanwhile, we're supposed to maintain operational readiness." Patterson learned that his weapon's problems reflected systematic flaws in the M60's design and manufacture. The receiver, stamped from sheet steel and welded together, lacked the structural integrity of machine components. Under the stress of sustained firing, welds failed and metal fatigued. The weapon's rapid adoption and rush production meant quality control had suffered. Contracts awarded to multiple manufacturers resulted in inconsistent parts tolerances, creating weapons that were theoretically identical but functionally variable. Tucker showed Patterson a classified technical intelligence report that had circulated among senior armorers. The document, compiled by Army Material Command engineers who'd analyzed failed M60s returned from Vietnam, identified 12 major design deficiencies. The gas system lacked adequate venting, causing carbon buildup. The feed mechanism's pulls were rapidly due to insufficient hardening. The quick-change barrel system, while conceptually sound, loosened under recoil stress, degrading accuracy. The report's conclusions were damning. The M60 required fundamental redesign before it could serve reliably in tropical combat conditions. Historical records maintained by the Army Center of Military History document the growing crisis surrounding small arms reliability during 1966. Thousands of M60s required repair or replacement, but the logistics system struggled to meet demand. Production facilities stateside ramped up output, but newly manufactured weapons incorporated the same flawed designs as their predecessors. Field modifications, improvised by creative armorers like Tucker, proliferated through unofficial channels, but such fixes addressed symptoms rather than fundamental problems. Patterson received a replacement weapon, one of the few available M60s not awaiting repair. Tucker had personally tested and adjusted it, selecting the least problematic weapon from available inventory. But even this good machine gun showed wear patterns and looseness that would have been unacceptable in peacetime. Patterson accepted it with grim understanding that perfection remained unattainable. He would make do with adequacy and hope that fortune favored him in the next firefight. The armorer offered parting advice gleaned from months of observing weapon performance. Shorter bursts preserved barrel life and reduced heat stress. Meticulous attention to the gas system's cleanliness prevented many stoppages. Carrying spare extractor springs and firing pins allowed failed repairs when components inevitably failed. Such wisdom, passed soldier to soldier, represented the real-world education that training manuals could never provide. As Patterson returned to his squad's area, he passed the battalion aid station where O'Connor recovered from his shoulder wound. The young private would survive, but he'd carry North Vietnamese steel the rest of his life. Patterson wondered how many American casualties resulted not from enemy skill, but from friendly weapons failures, a question that statistics would never adequately answer, but that every combat soldier understood intuitively. The M60's failures weren't just mechanical problems, they were measured in blood and lost lives. March 3, 1966. The wisdom of combat experience began flowing through informal networks as soldiers developed workarounds for the M60's endemic problems. Patterson attended a company-level training session where veterans shared hard-earned knowledge with newly arrived replacements. Staff Sergeant Marcus Washington, a machine gun section leader with 2 combat tours, conducted the instruction with the intensity of a man who'd watched soldiers die because weapons failed. Washington demonstrated modified carrying techniques that distributed the M60's weight more effectively during jungle movements. He showed how to wrap ammunition belts in plastic to reduce moisture exposure, then store them in improvised pouches cut from poncho material. He explained the critical importance of the assistant gunner's role, emphasizing that Chen's load of spare parts and accessories wasn't optional equipment, but survival gear. The sergeant revealed modifications that armorers officially discouraged, but that combat veterans swore by. Carefully filing and polishing the feed tray's contact surfaces reduced friction and improved reliability. Replacing standard recoil springs with slightly heavier versions reduced the weapon's rate of fire, but decreased mechanical stress and extended component life. Wrapping exposed metal surfaces with cloth tape prevented corrosion and improved grip during rain-soaked operations. Patterson learned about ammunition selection's critical importance. Not all 7.62mm NATO rounds performed identically. Ammunition from certain manufacturers exhibited more consistent performance, while other lots caused excessive fouling or demonstrated poor ignition characteristics in humid conditions. Experienced gunners cultivated relationships with supply sergeants, trading favors for access to preferred ammunition stocks. Combat experience also revealed tactical adaptations necessitated by the M60's limitations. Lieutenant David Foster, a platoon leader with 8 months in country, explained that firefight doctrine had evolved to accommodate weapon reliability issues rather than sustain suppressive fire. Envisioned in training manuals, effective employment required short, controlled bursts interrupted by frequent barrel and position changes. The M60's unpredictability demanded backup plans and redundant firepower. According to a comprehensive study conducted by the Combat Development Command and later published in military professional journals, American infantry tactics in Vietnam underwent significant modifications specifically to compensate for M60 deficiencies. Squads learned to position multiple automatic weapons to ensure overlapping fields of fire, providing redundancy when individual weapons failed. Radio procedures incorporated specific code words for weapon malfunctions, allowing commanders to rapidly adjust tactical plans when machine guns went silent. Patterson absorbed these lessons, understanding that survival depended on adapting to the M60's quirks rather than fighting against them. He developed an almost ritualistic maintenance routine, performing specific tasks in precise order each evening. He learned to recognize subtle changes in the weapon's sound and feel that indicated developing problems. He memorized the location and function of every component, capable of performing emergency repairs by touching complete darkness. The bond between Patterson and Chen deepened into the symbiotic relationship, essential for effective machine gun team operation. Chen anticipated Patterson's needs before spoken words, knowing when to feed ammunition, when to prepare a barrel change, and when to take over firing to give Patterson's arms respite from the weapon's weight and recoil. They developed hand signals and silent communication methods, coordinating actions under conditions where voice commands invited enemy fire. Other soldiers offered their own innovations. Some gunners cannibalized parts from multiple weapons to assemble one reliable machine gun. Others discovered that certain cleaning solvents worked better than issued lubricants in Vietnam's environment. A few talented machinists fabricated improved components using salvaged metal and improvised tools. Such creativity represented American ingenuity at the individual level. Soldiers compensating for institutional failures through determination and resourcefulness. But adaptation had limits. No amount of clever modification could overcome fundamental design flaws. The M60 remained a temperamental weapon that demanded constant attention, and still failed unpredictably. Patterson and his fellow gunners carried their burden with resignation, knowing that military procurement decisions made years earlier in air-conditioned Pentagon offices now determined whether they lived or died in the jungle. June 18, 1966. Operation El Paso II brought Patterson's battalion into the Condom Province highlands, pursuing North Vietnamese regulars who'd ambushed a supply convoy. The terrain rose sharply, triple canopy jungle giving way to steep ridgelines where every step required conscious effort. Patterson's M60, despite months of careful maintenance, felt heavier than ever, the weight multiplied by exhaustion and oppressive heat. Sergeant Davis pushed the squad hard, knowing enemy forces had fortified positions somewhere ahead. Intelligence reports indicated at least company-strength NVA units dug into bunker complexes, equipped with heavy weapons and prepared to defend their ground. The battle, when it came, would test every weapon and every man to breaking points. Contact occurred at 1400 hours. NVA machine guns opening fire from concealed positions along the ridgeline. Patterson ducked for cover behind a fallen log as rounds cracked overhead. He swung the M60 into position, acquiring targets through gaps in vegetation. The weapon fired beautifully for the first 50 rounds, then the nightmare began. The barrel's carrying handle, already loosened from months of use, separated completely, leaving Patterson without means to change the overheating barrel. Chen scrambled forward with a spare barrel, but the damage was done. Without the carrying handle, barrel changes required bare hands on scorching metal, an impossibility during sustained fire. Patterson continued firing in short bursts, praying the barrel wouldn't fail catastrophically. The weapon's accuracy degraded as metal expanded beyond tolerances, rounds spraying wide of their aim points. He watched tracers arc into the canopy instead of into enemy positions. 50 meters to Patterson's left, Specialist Martin Hayes experienced worse fortune. His M60's receiver separated at a welded seam, the entire top cover assembly tearing loose under recoil stress. Shrapnel from the failed component struck Hayes in the face, temporarily blinding him with blood. The squad's second machine gun was silent, leaving Davis's men with half their firepower just as the NVA counterattacked. The enemy advanced in disciplined rushes, using terrain expertly. AK-47s and RPD light machine guns provided covering fire while assault troops maneuvered. Davis called for artillery support, but shells took precious minutes to arrive. Patterson burned through ammunition at unsustainable rates, knowing that if his weapon failed now, the squad would be overrun. His barrel glowed white-hot, warping visibly, but still he fired. Historical accounts of Operation El Paso II, compiled from after-action reports and eyewitness testimonies, document the brutal reality of mechanized warfare when machines failed. 1st Battalion, 14th Infantry Regiment suffered 37 casualties during 3 days of fighting, and subsequent investigations revealed that weapon malfunctions contributed directly to at least 11 deaths. M60 failures during critical moments left American positions without suppressive fire, allowing enemy forces to maneuver with impunity. Artillery finally arrived, high explosive rounds walking up the ridge line toward enemy positions. The NVA withdrew under the bombardment, leaving the battlefield to exhausted Americans. Patterson's barrel had warped so severely the weapon was unusable. Hayes sat against a tree, field dressing covering his lacerated face, his destroyed M60 beside him. The squad had survived, but only through fortune and artillery support, not because their primary weapons had performed as designed. Captain Reynolds toured the company's positions after the battle, documenting weapon failures for his mounting file of reports. 22 of 36 M60s in the battalion had experienced significant malfunctions. During the operation, component failures ranged from minor issues like broken firing pins to catastrophic receiver separations. Reynolds' report concluded with a stark assessment. Current M60 machine guns cannot sustain combat operations at required intensity without unacceptable failure rates. Patterson received yet another replacement weapon that evening. This one cannibalized from multiple damaged M60s to create one functional gun. Tucker the armor had worked through the night, selecting the best available components and assembling them with meticulous care. But even Tucker's expertise couldn't restore Patterson's confidence in the weapon. He'd witnessed too many failures, heard too many horror stories from other gunners. The M60 had become a burden carried not just on his back, but in his mind. September 27, 1966, Colonel Thomas Grant, assigned to Army Materiel Command, arrived in Vietnam with a team of civilian engineers to investigate small arms performance. Their mission represented belated acknowledgement that weapon failures in combat theaters demanded immediate attention. Grant established a temporary office at Long Binh, interviewing soldiers and examining disabled weapons flowing through repair channels. Patterson found himself summoned to provide testimony. One of hundreds of machine gunners interviewed during the investigation, he spoke candidly, describing malfunctions he'd experienced and witnessed. Grant's team took detailed notes, photographed damage patterns, and collected failed components for metallurgical analysis stateside. For the first time, Patterson felt that someone with authority actually cared about the problems soldiers faced daily. The investigation revealed uncomfortable truths about the M60's development and procurement. The weapon had been rushed into production during the late 1950s, driven by Cold War urgency to replace aging World War II-era machine guns. Design testing occurred primarily in temperate climates, with insufficient evaluation under tropical conditions. Manufacturing contracts, awarded based on cost rather than quality, resulted in inconsistent production standards. The Army had fielded a weapon system without adequately validating its performance in environments where it would actually be used. Grant's preliminary findings, documented in a report classified secret but later declassified, identified systemic failures throughout the acquisition process. The M60's design incorporated components from multiple foreign weapons: the German MG-42's operating system, the American M1919's trigger mechanism, and the Swiss MG-40-59's feed system without adequate integration testing. The resulting hybrid exhibited incompatibilities that became apparent only under sustained combat use. Manufacturing quality control proved equally problematic. Civilian contractors, unfamiliar with military specifications, produced components with excessive tolerances. Sheet metal receivers, stamped and welded rather than machined, lacked consistent strength characteristics. Heat treatment of critical components varied between production lots, causing unpredictable wear patterns. The Army's own quality assurance inspectors, overwhelmed by production volumes, approved weapons that barely met minimum standards. Historical analysis conducted by military historians and detailed in publications examining Vietnam-era logistics revealed broader institutional failures. The Army's rigid procurement system, designed during peacetime, couldn't adapt rapidly to combat feedback. Modifications required lengthy approval processes, engineering studies, and budgetary authorizations. Meanwhile, soldiers fought and died with flawed weapons.